Dr. K. Parinivelu, Professor at the Center for Environmental Studies and Director of Center for Climate Change and Disaster Management, Anna University, Chennai. He obtained his PhD degree from Indian Institute of Technology, Madras, Chennai. He worked as project officer for a brief period at IIT Madras and moved on to the Center for Environmental Studies, Anna University in 1992. He was a visiting professor at Chungam National University, South Korea during 2007. He has been teaching courses on environmental chemistry, environmental pollution control, and instrumental methods of analysis since last 27 years. He has guided 75 students for ME and MSc, 4 MPhil, 2 MS, and 15 PhDs. He has published 135 papers in journals and 90 in conference and symposiums. He has received several awards in national and international levels.
Welcome to the lecture series on chemistry of environment. Today we are going to discuss about some of the chemistry behind the hazardous waste and its management. Usually waste is an unwanted material. Normally we will throw it, and usually if you look at it, any waste that are not products or byproducts for which the generator has no further interest or use for the purposes of production, transformation and consumption. Okay. It is an unwanted material. Usually whoever it is, if it is not a product or byproduct, they may not be interested. Such material we will call it as usually as a waste. Okay. Suppose the waste is hazardous in nature, that is going to create a lot of environmental issues, okay, starting from health to other, so many other issues are likely to originate from this hazardous waste. So, what is this hazardous waste? It is a hazardous substance that has been discarded, abandoned, neglected, released, or designated as a waste material, or one that may interact with the other substances to be hazardous. Okay. So, that means hazardous in the particular material, even it suppose it interact with the other material producing some hazardous character, that it becomes hazardous waste. Okay. And hazardous material normally cause problems when they enter into the environment and have detrimental effect on organisms or other part of the environment. So, such type of materials are considered the hazardous material. Usually these hazardous waste attributes, such as attributes, is based on its nature of the waste, its composition and inherent characteristics. All these things attribute towards a hazardous waste. That is what nature it possesses, what are the composition and its inherent characteristics, everything determines the hazardous waste. Its main worry is if these hazardous material, if they enter into environment, definitely they are going to cause lot of detrimental effect to organism, human being and as a environment as a whole. So, what are this characteristics of this hazardous material? What type of material we call it as a hazardous? And there are 4 specialized characteristics which denotes this as a hazardous material, called CRIT properties. That is, C stands for corrosivity, R for reactivity, I for ignitionability and T for toxicity. If any waste possesses all the 4 characteristics, then particular waste is considered as hazardous waste. Let us see one by one what are this. First, let us look at what is corrosivity. If a waste become or possess corrosive nature, that waste is considered as corrosive waste by hazardous nature. That is, corrosivity, characteristics of a substance that exhibit extremes of acidity or basicity or a tendency to corrode steel. So, this is a special property. The waste material should be of extreme acidity or basicity, or it should have a tendency to corrode steel. Waste in terms of pH, if it is measured, that is outside the range of 2 to 12.5. That is, any waste material acidic will have less than pH value 2 is considered as a corrosive waste. Similarly, any material which have alkalinity value, basicity value in terms of pH measurement above 12.5, that waste also considered as corrosive waste. Or the material should be able to corrode steel, that is at a rate of greater than 6.35 mm or 0.25 inch per year. Steel, if it is getting corroded at this rate, then that waste is also considered as corrosive waste, either by pH measurement or by corroding nature of the particular steel. That type of all these waste are considered as a corrosive waste. For example, metal cleaning solution bearing acids. In metal cleaning, sometimes we use acid. That waste is considered as a corrosive waste. Similarly, electroplating industry is the one which generate huge amount of corrosive waste. The other property is reactivity, that is characteristics of the hazardous substance that have a tendency to undergo violent chemical change, that is reactivity. For example, explosive, pyroporic materials, water reactive substances, or cyanide, sulfide bearing waste. So, all these waste are considered as a reactive hazardous waste, because sulfide, the moment it reacts, especially acidic condition, generate huge amount of hydrogen sulfide, that it becomes a nuisance and kills many people. And highly toxic cyanide, again if it contacts with any acid, liberate highly toxic hydrocyanide gas, again becomes toxic. And if you consider water reactive substances, for example sodium, and the moment when it is getting exposed to water, it will react. Similarly, phosphorus. So, all these type of material will undergo a reaction violently. That type of materials are called reactive waste. The third property is ignitional property of the particular hazardous waste. What is this? The characteristic of the substance that are liquid, that is the vapors of which are likely to ignite in the presence of ignition sources, and non-liquid that may catch up fire from friction or contact with the water, and which burn vigorously or persistently, that is ignible compressed gases and oxidizer thing. So, such type of property is called ignible waste. Okay. So, these type of hazardous ignible waste are those which may cause a fire during the storage, transportation and disposal. Any hazardous waste, these are the things. Wherever it is generated, usually that waste will be stored, transported for disposal. During any one of the step, it causes fire, then particular waste is considered as ignible waste. And the United Nations EPA, Environmental Protection Agency, defines ignibility in terms of the material, splash point and other characteristics. Okay, that is all highly ignible. For example, gasoline waste is considered as a ignible waste because it undergoes easy fire. And the fourth property, very important one, from especially from environmental angle, is the toxicity. How toxic these waste are, and these toxicity is defined in terms of a standard extraction procedure followed by chemical analysis for specific substances of listed chemical substances which are all highly toxic in nature. And toxic waste are defined by a rigorous test procedure. Okay. And the toxicity characteristics leachate procedure is a current one. Earlier also EP toxicity, extraction procedure toxicity was there. Now, this is what used currently, the TCLP, again established by US EPA to find out if the particular waste is hazardous in terms of toxic nature or not, is carried out by TCLP test, that is toxicity characteristics leachate procedure. What is this TCLP? One of the very important tests carried out to determine a particular waste is hazardous or not in terms of its nature as a toxic one. Usually, the mobility of organic and inorganic contaminant in waste material, it determines. The TCLP test, by determining, it will tell you whether a particular organic or inorganic waste is mobile or not by conducting this test. And hazardous and non-hazardous waste for disposal in the appropriate landfill. Before disposal, any hazardous waste, whether the waste is fit for landfill or not, is again determined based on the TCLP test value, because after disposal, from that there should not be any leachate, and that is because of the mobility, it should not be leached out. and how percolating liquids may react with the solid waste in simulated landfill conditions also. That information also the TCLP test determines. And what possible public health or environmental health hazard exists in the sludge being tested. So, what is this actually? How it is carried out? Usually the TCLP test is a laboratory based test. It has to be conducted with the help of appropriate instruments to carry out this. And TCLP tests, for example, the hazardous waste sample actually involves a extraction method for chemical analysis being employed for this. This ultimately after the extraction, and it is subjected to analytical determination of a particular pollutant, and this test actually simulate leaching through a landfill. Ultimately, by subjecting to this test, the information will produce whether a particular waste, suppose if it is dumped in a landfill, in a designated hazardous secured landfill, what about the leaching nature of this one? It's what information, main information we get it. And what are the procedure involved in this carrying out the test? Because the hazardous waste sometimes may be a slurry, liquid form, or mostly in the solid form. If it is a very high solid but the particle size greater, the particle size should be reduced first, because as a bulk material they may be available in the actual industry. That sample has to be collected and the particle size should be reduced to less than 1 centimeter before subjecting the test. That is the first step. Any bulk particle, the size should be reduced to less than 1 centimeter. Okay. And then next, by checking the pH of the particular waste, there are two fluids available. Okay. And the test is usually conducted with leaching is with the acetic acid employing a pH 3 or 5. Suppose the waste pH is highly alkaline, you have to go for a pH 3 based acetic acid solution. Suppose it is near neutral, then you can go for pH 5 based acetic acid. The purpose of using acetic acid is to generate the simulate condition, simulating the leaching actually happening in the landfill, because any organic materials there, that will be slowly converted, and one of the important product is acetic acid. So, that is likely to react with this heavy metal bearing substances and likely to leach out. So, that is why acetic acid is taken as testing fluid or leaching agent to conduct this test. Okay. So, depending on the pH of this actual original material, either pH 3 or 5 based acetic acid solution is used to carry out the test. And normally it is 1:20, 1 part solid waste is taken with 20 part of this acetic acid, liquid portion is taken, and this is mixed RPM of 30 RPM for 18 hours at least, 16 hours minimum, it can go up to 20 hours also, 18 plus or minus 2 hours, it can be conducted 18 hours, and the RPM should be at 30 plus or minus 2 RPM. And there are some specialized TCLP tests. It is not a kind of orbital shaker, should not be used for carrying out the shaker. In the laboratory, normally any shaking, normally we will do it in an orbit way, but it should rotate in this way. Okay. The sample should be rotated thoroughly in a mixing with acetic acid, so that the entire portion of this small particles of this solid waste is getting exposed and ultimately leached out. So, the laboratory based orbital shaker may not be good for this TCLP. There are specialized bottle should be used for carrying out this, and especially for organic containing volatile organics, the things are there, and the bottle used should be there should be a provision for zero head space extraction. There are bottle with zero head space extraction that should be used, that is without any air column in the bottle, should be used, adjusted properly, and that should be used for extracting this volatile organic compounds. Otherwise, at the end of the experiment we may lose some volatile organics things. So, this is a procedure to be carried out to test a particular waste is hazardous or not in terms of toxicity. After this, what to do? After conducting the test, we have to test the various heavy metal, toxic, organic, pesticides, etc., and check whether it is within the limit or not. For example, these are the TCFP limit or standard, and the waste normally meant for disposal in a dump site should not have values more than this. The moment it exceeds this value, for arsenic it is 5 ppm, barium 100 ppm, barium is also hazardous, 100 ppm, cadmium 1, chromium 5, lead 5, mercury 0.2, selenium 1 and silver 5. So, all these are metals which are considered as toxic, and after the end of the TCLP test, if any hazardous waste having value above this, definitely that waste is not fit for landfill. It should be chemically stabilized or chemically fixed, and then only till the value comes below this, that should be stabilized. Otherwise, the waste values TCLP test results are more than this, definitely that waste is not fit for direct disposal into landfill. And if you look at the values, usually it is 100 times of the drinking water standard of a WHO standard. For arsenic, it is 0.05 milligram per liter, whereas TCLP test is 100 milligram per liter. So, roughly 1000 times, I am sorry, 100 times more than the drinking water standard for almost all of these constituents. Even organics like pesticides are controlled by this. The TCLP regulatory level should not exceed this value. For chlorine, it is 0.03, endrine 0.02, heptachlor 0.008, lindane 0.4, methoxychlor 10, and this it is 0.5. So, all these values indicate how toxic they are. Heptachlor you see 0.008, whereas methoxychlor it is 100. So, these values indicate compared to this methoxychlor, heptachlor is more toxic. And similarly, we have standards for herbicides also, 2,4-D and 2,4-T, it is all regulatory limit. So, any hazardous waste arising should be checked for TCLP procedure and compared with the limit, and then it should be decided whether it is direct fit or it should be stabilized further before disposal. And coming to India, what is the status of hazardous waste management really? And as per our Indian hazardous waste rule, earlier it was framed in the year 1989. That time we had 18 categories of list, and recently it is all revised, and we have a specified column and schedule, and all the waste processes are mentioned that is considered as a hazardous waste. It is actually grouped into 5 groups, limits are given, and we have to check the column and schedule whether a particular waste is hazardous or not. And the rules also define, as per our Indian rule, the hazardous waste is considered any waste which by reasons of characteristics such as physical, chemical, biological, reactive, toxic, flammable, explosive, corrosive, or causes danger or is likely to cause a danger to health or environment, whether alone or in contact with the other waste or substances, and shall include all these things listed in the schedule of our hazardous waste rule. Okay. So, India also we are going for this. A lot of changes, amendment are happening to this rule, and this latest rule is amended in the year 2016. Earlier one was 1918, where we had 18 categories of listed waste. So, these are the waste. Know the thing, it should be managed as per the hazardous waste rule, how it should be handled and managed. And some of the hazardous waste from non-specific source also likely to come. For example, common halogenated degreasing solvents. For removing the grease, we use normally organic solvent, especially halogenated solvents, dichloromethane type of things are used. Remove the grease in any objects, especially metal, and this is a hazardous waste again. TC trichloroethylene is one of the such thing. And electroplating waste and waste from metal heat treating and recovery plant. So, all these things are hazardous waste from non-specific sources that also has to be managed as hazardous waste. In managing this hazardous waste, what is important is any waste we should see the concepts of recycling. What are the various possibilities so that the waste can be recovered, recycled, reused, and this is all called waste minimization. That should be paid attention. Waste minimization for hazardous waste also very important. So, the best way is we have to see possibility of avoiding generation of hazardous waste. That is the first one. The hierarchy cone goes like this. First one is avoid. There should not be any possibility of generating hazardous waste. If not possible, look for next option is recycle it. The waste is somehow is generated. Is there any possibility of recycling or reusing? That is very important. The third one is energy recovery. Is it possible to get some recovery of energy from that waste by incinerating it? That is possible, that should be explored. If not possible, then certain waste has to be incinerated without energy recovery also, and nothing possible, that is to be disposed in a landfill, in a secured landfill, in a scientific manner. Okay. So, these are the various options of managing hazardous waste as a part of waste minimization program of hazardous waste. This is also very much applicable. So, the waste management of hazardous waste, first priority is waste minimization, that is the elimination or reduction of waste prior to its generation. Using already we discussed about green chemistry, using that concept we ought to see is it possible to minimize the generation of such waste. Recycling, that is the reuse of the waste products either by directly reusing the material or by reclaiming some component present in it and then reuse it elsewhere. Okay. That is a part of recycling. And then source reduction, the elimination or reduction of a waste at its source by modifying the process that produces it. So, waste minimization, which incorporate recycling, resource reduction of the particular thing, everything you have to pay attention as a part of the hazardous waste management, and this is really the best way rather than incinerate and then dispose it of. Coming to treatment and disposal of the hazardous waste, as I mentioned before, the waste should be test for TCLP test, whether it is within the TCLP allowable limit or it exceeds, that we have to pay attention. Suppose it exceeds the TCLP characteristics value prescribed by US EPA, then that particular waste should be treated before disposal. Some amount of treatment is required using both physical and chemical treatment to fix the leaching hazardous constituents out of it. Some of the methods available are precipitation and coagulation is one which is very useful, especially for metal related hazardous waste. Similarly, oxidation and reduction, adsorption and other processes can be utilized for treating the hazardous waste, so that it is fixed chemically and meet the TCLP test requirement before disposal. And the waste, there are two ways. The physical treatment should go to the landfill after checking. Otherwise, the waste we have to look for, especially if it is organic waste and possess calorific value, we can attempt incinerate it, burn it, possible to recover energy out of it also. And especially for inorganic based waste, chemical fixation, also popularly called stabilization solidification, solidify and stabilize the waste so that it meets the requirement. Okay. Mainly this is used for inorganic metal bearing waste, and the logic is here the stabilization solidification process, whatever the particular metal available in the original native occurring form, that we have to pay attention. For example, if we consider mercury, that is available as a cinnabar, mercury sulfide. Any metallic mercury is coming, that should be converted into sulfide mercury, not as a hydroxide, because in the leaching procedure TCLP we cannot meet the limit of mercury. So, only if it is stabilized with the sulfide, then it may meet the TCLP norms. Okay. So, this solidification, stabilization or chemical fixation is one of the important thing before it is landfill. And here the chemical fixation is a term for several methods or chemically immobilizing hazardous material into cement, plastic or other matrix also used. Cement is mainly used for inorganic things and plastic especially for organic toxic material. So, this depending on the nature of the base material we can select, and ultimately if it is stabilized and ensured it meets the TCLP norms, it can be disposed in a landfill. That is a PACA scientifically secured landfill is used for this. So, in short, if you say the hazardous waste, how it is disposed, as there are main two ways, one is incineration, the other one is landfill. We can make a comparison. Suppose human being we dying, the waste is managed in two ways, either we will go for burial or incinerate it. So, same way the hazardous waste, how we treat the dead body, same way it should be treated. If it is an organic one, go for incinerating it. If it is not, if it is an inorganic, stabilize it and put it into the native form. Okay. So, this is the one of a landfill. So, to sum up, hazardous waste is one of the important topic of environmental management. First, we should know what is this hazardous waste, what are the properties, the four properties: corrosivity, reactivity, ignitionability and toxicity. We have to check and ensure whether it is hazardous or not. Also, there are rules available whether it is a listed waste in the country. In India also we have hazardous waste rule and we have to check for this, and based on the nature what type of treatment is required or disposal is required, that should be evaluated, and the hazardous waste should be either incinerated if it is having a calorific bulb, organic based one, and if it is a inorganic one, stabilize it and put it in the landfill. How originally we got a particular material from nature, that way it should be managed. With this we have come to the end of this hazardous waste. Thank you.